Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Phthalate is the cyclic imide derived from phthalic anhydride and ammonia, i.e. isondol 1,3,2H-dione. When treated with NaOH, aqueous base, the following occurs. Moving on to the next step. Phthalate, cyclic imide, undergoes base hydrolysis. NaOH acts as a nucleophile base to hydrolyze the imide CN bonds. Moving on to the next step. The cyclic imide has two amide CN bonds. Under basic conditions, NaOH hydrolyzes both CN bonds of the imide ring. This ring opening hydrolysis converts the cyclic imide into the dicarboxylate, phthalate, salt plus ammonia. And for the final step, the product is the disodium salt of phthalic acid, sodium phthalate, where both carboxylic acid groups are present as sodium carboxylate, CONA, groups on the ortho positions of the benzene ring. However, looking at option C, it shows a benzene ring fused to a 6-membered ring with 2 ONA groups, and to C is equal to O groups. This represents the disodium phthalate where both carboxylate groups have been converted to CONA, i.e., the ring has opened and both amide nitrogens replaced by ONA oxygens, giving the orthodicarboxylate disodium salt. Option A shows an ester-linked dimer, not the product of simple NaOH hydrolysis of phthalate. Option B shows a diol, reduction product, not relevant to base hydrolysis of an imide. Option D shows a dilactone, which would require acidic conditions or specific esterification, not NaOH treatment. The major product of treating phthalate with NaOH is the disodium phthalate salt, the ring-opened hydrolysis product with 2 CONA groups, corresponding to option C. Therefore, the correct answer is C. Therefore, the correct answer is option C.